The agony of the old way. Imagine a mold design with over 50 lifter assemblies. In the old manual design process, each of these lifters would need to be created individually from scratch. Some business has moderately sufficient data. Majority of designers has their own stash of data to run design process. Let's not assess creating from scratch, but look into different scenario. A mold design contains 50 plus lifters. After design review, a change is requested. Increase the lifter rod angle be 1 degree and thread rod length be 5 millimeters to accommodate a slight modification in the product's undercut. Modify individually. Each lifter is a unique dumb solid body. There are no intelligent links. For each of the 50 plus lifters, the designer must disassemble the group of components. Manually redraw the angled hole in the lifter block based on the new angle, ensuring it doesn't interfere with other components. Manually recalculate the new travel path and required clearance. Extend the rod length, modifying spacer pipe behind it, repositioning lifter slide housings. Check and adjust all associated components, the bushings, the retainer plates, and the clamping, screw lengths. 2. Human error amplified. This repetitive process must be performed 50 plus times. The risk of a single mistake, a miscalculated angle, a missed interference is incredibly high. A single error in one lifter could cause the entire mold to fail during testing. 3. Time sink. What seems like a simple change easily consumes days of tedious, error-prone work. 50 configurations times 1.5 hours results to 75 hours of design time, leading to massive delays and skyrocketing error chances within existing project timeline. List is long for a design engineer. The crisis, our current reality. We are trapped in a vicious cycle. Underbidding and bad estimates. We guess on design time because we have no consistent benchmarks. Chaotic execution. Every task is urgent, leading to constant context switching and mistakes. Lack of mentoring. Seniors are too busy spending time on repetitive low-value tasks like manual geometry creation, firefighting to train juniors, perpetuating the cycle. Infinite workdays. Heroic efforts are the norm just to get projects out the door. Result: plummeting profitability, exhausted teams, and a reputation for delays. The root cause: variability and reinventing the wheel. Our biggest time sinks and cost overruns come from non-value added repetition. Example: designing 50 lifters manually for every new project is not skill design work, it's skill waste. This manual variability makes accurate estimation impossible and turns every project into a high-risk gamble. Our strategic sheet: automated standard part libraries. What is it? A single source of truth for standard components. For example, our lifter assembly. It's not just a CAD tool, it gets into a business process that directly attacks our biggest problems. The power of automation. How standardized libraries rescue profitability and sanity in mold design. From wild guesses to accurate bids. Problem: underbidding and lack of realistic estimation. Solution: libraries provide predictable, measurable design times. How it works. Before: how long to design 50 lifters? A guess based on hope. 3 days. After: how long to design 50 lifters? A calculation based on data. Inserting 50 library components takes 50 minutes. Customizing them might take 2 hours. Total to 3 hours. Bottom line: we can finally bid based on data, not desperation. This protects whole process down the line on every project. Taming the chaos and stopping task switching overhead. Problem: zero priority system and constant urgent changes. Solution: libraries make changes fast and non-disruptive. How it works. The old urgent change. A client asks to change the lifter angle. This triggers a days long manual nightmare across 50 parts, derailing all other work. The new urgent change. Change one parameter in the library table. All 50 lifters update correctly in minutes. You resume your other work. Bottom line: we drastically reduce the impact of urgent requests. This minimizes context switching, protects project timelines, and reduces execution chaos. Automated mentoring and force multiplied talent. Problem: lack of mentoring and upskilling. Solution: libraries bake expert knowledge into the software itself. How it works. A junior designer doesn't need to be mentored on the correct screw size, dowel pin, or bushing length for a diameter 16 mm lifter rod. The library automatically applies this expert knowledge for them. They learn by using correct, pre-validated designs every time. Bottom line: we upskill our entire team faster. Junior designers produce expert-level work immediately. Senior designers are freed from constant supervision and can focus on truly complex problems, reclaiming time and ending the infinite workday. Problem: infinite workday culture and chaotic execution. Solution: libraries automate the repetitive grind that consumes our evenings and weekends. How it works. The tedious Manual labor of creating and updating standard parts is eliminated. What used to take 40 hours now takes 1 hour. This is not an exaggeration. Bottom line, we claim hundreds of engineering hours per project. This is the only way to stop the burnout cycle, improve morale, and get our weekends back without sacrificing deadlines or quality. The power of automation, how standardized libraries rescue profitability and sanity in mold design. Conclusion, an investment in survival and growth. Standardized libraries are not an IT project. They are a strategic necessity for our survival and profitability. They are the key to winning bids by costing them accurately, executing calmly by making changes trivial, building talent by embedding knowledge in our tools, working smarter by eliminating the grind that burns us out. Call to action. Let's stop being heroes fighting fires. Let's build a system that allows us to be consistent, profitable, and calm engineers.